So we're going to talk today as a good introduction to the engineering problem-solving process, which you'll hear me call the process. Just like if you're a football fan, you know that Nick Saban, the coach of Alabama, has something called the process, and that's attributed to his remarkable success wherever he's gone at both LSU and at Alabama. And engineers, we have a process, and successful engineers understand the process and know how to apply the process because it becomes very important. So you'll see variations of the process with many steps, but these can basically be distilled down into these 5 simple steps. So the first step is identify the problem. And that becomes important. To know how to solve a problem, you have to know what the problem is to begin with. And a lot of times we might not necessarily do that. So it'd be like asking you to write a program but not telling you what I want the output to be. Oh, just write me a program. And you're like, well, what's this program supposed to do? Well, I don't know. Well, how would you be able to write a program if you don't know what the program is supposed to do? So you have to identify the problem, and that becomes important into identify the problem. What exactly is the problem? And when you identify the problem, you want to identify who the users are, for example, because that becomes important too. Is this a problem for a particular group? Is this a problem for the designers? Let's use we'll use my favorite traffic signals. So let's say a traffic signal is malfunctioning. Well, first we have to identify what is the malfunction. Is it that traffic is holding up? Is it that somewhere in the computer programming that it's not functioning as it should, but the people in the outside world, the traffic, don't even notice it? Like, for example, when a detector goes out, a signal will go into an override mode. And what that is it's like a pre-timed, pre-programmed mode. So a lot of your signals sometimes are what we call smart signals. And when traffic comes up, it'll cause the signal to change. A lot of times, especially at like peak hours, for example, we'll run traffic signals on a pre-timed mode, where it'll just say, I'm going to switch every 30 seconds. That's it. Just to keep, and that's if we have like a progression system. So, for example, if you drive out Woodward or like Telegraph Road is a great example, has a very good progression system. And if I go a correct speed, I can hit green, 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 green all the way down Telegraph Road. And I've actually done that all the way and been able to almost successfully hit every single green all the way from Elizabeth Lake Road down to 12 Mile, because there's a progression system. And progression systems will go on a preset timing pattern. Well, sometimes when the detectors go out, it'll tell the signal itself to go into a pre-timed mode. So that's not really a problem for me as a driver because I'm not noticing any difference anyway. That's a problem for me as the technician or the engineer, that there's a malfunction somewhere in my hardware or my software that's causing this signal to overwrite itself into a pre-timed mode. So when you identify the problem, it's important to identify the users. Who is that a problem to? And that becomes important to know when you identify the problem. So that's step 1. So identify your problem, and as when you identify the problem, identify who the users, the end group, who is this a problem to? Who are we trying to reach out to solve this problem for? Because what may be a problem for some, like my example with the signals, may not be a problem for others. So when a signal goes into recall, it may not be a problem for the motorist. They're not going to notice any difference, but it's a problem for the technician. The second step in the process is to identify possible solutions. Um, there are many, many, many solutions to a single problem. And there may not necessarily be one solution. And so it's important as part of the process to identify these possible solutions. Now, some are just ridiculous. Let's take, for example, our signal. Our signal is going on recall mode, and it would be absolutely ridiculous if I have a signal, let's say on Telegraph Road, and one of my solutions is, I'm just going to turn the signal off. That's not a very good solution. It's not a very realistic solution to what the problem is. So, when you start identifying possible solutions, part of this identification is eliminating the solutions that, are just not practical, what I call ridiculous solutions. It'd be like going to a doctor because, I need stitches, and the doctor says, I'm going to amputate your leg because you need stitches. I got a bee sting, I'm allergic to bees. Oh, we're just going to chop it off. That's technically a solution, but is it a very good solution? Or my plumbing's leaking. I got a leaky toilet. Okay, we'll tear down your house because your toilet leaks. Yeah, that would solve the problem. I tear down your house, you're not going to have a leaky toilet anymore. But is that really a good solution? So when you start identifying possible solutions, you want to start eliminating the ridiculous ones. But then that kind of takes you right into a segue of step 3 is identify possible outcomes. So when you do your solutions, you also want to try and think, okay, if I implement solution A, what are going to be the possible outcomes? So for example, let's say my recall mode signal. One possible solution is I do nothing. Well, what's the possible outcome of that? Well, my delay may not be harmed at all. So my possible outcome may be really not a negative effect, or the negative effect could be that off-peak hours I'm stuck with the pre-timed signal that's causing excessive delay and excessive waste because I can't go into a free smart mode detection mode because the detector's out. So that becomes a possible outcome. So identify the possible outcomes, and when I'm identifying outcomes, it's always good to throw in constraints and cost. What's the cost of doing this? Is this going to become feasible to do this when I identify possible outcomes? So that's part of that process 3. Or as you'll see from the video, an engineer in store 515, possible outcomes of how you color code it is, what if you're colorblind? So what if you choose colors that a colorblind person, and the most common color blindness is between green and shades of red. So what if you choose colors that a colorblind person can't distinguish between the two colors? That's a possible outcome. So we need to think about outcomes too when we start looking at solutions. So you've got your list of solutions now. You've got your list of possible outcomes, and you're not going to be able to come up with every outcome, but this is where working with a group with different points of view becomes very helpful, is in steps 2 and 3. Because if we're in a group and we all have the exact same worldview, so let's say I am a 50-year-old white man. So let's say I'm in a group of also 50-year-old white men. Well, we're only going to come up with solutions that 50-year-old white men are going to think of. So it's always a good idea to bring in maybe some younger men, maybe men of different backgrounds, different ethnicities, maybe some women of different ages and different ethnicities, to broaden that mix. And then and different educational backgrounds. I'm adjunct faculty. So I'm going to have a completely different worldview, and if I just only pull adjunct faculty, we may get the exact same answer. This is where students help, because students may have a different perspective on it than the faculty do. So there's, different worldviews. And so when you start identifying solutions and outcomes, it's always important to try and get as diverse a group as possible uh, to come up with things that your worldview you may not have experienced or may not think about. The fourth step in the process is select a solution. So after you've gone through 2 and 3, you've identified your solutions, you've identified your outcomes, then pick one. And, I'm just going to say, you just pick one and go with it. Be firm. You can't vacillate forever. So you have to pick a solution. And then finally, and this is a critical step that a lot of people don't like to do, you evaluate your solution. So implement your solution and then compare the actual outcome with your assumed outcome. So when you did your steps 2 and 3, and especially step 3, and you're going, okay, if I do solution A, here's what the outcome is going to be. Now, let's say I implement solution A. So that was my solution. And then once I put it in there, I want to evaluate that. I want to compare what actually happened with what I thought would happen. And this becomes a very critical part of the engineering problem solving process. So let's say I implement solution A and it didn't come out with the results I expected. Well, then what I need to do is I need to go back and evaluate the assumptions. Where did I make a mistake? What assumptions were wrong when I did that step 3 of evaluating outcomes, so that we can throw those discrepancies in there so that the next time that we come up with these evaluations and we're trying to predict an outcome, that we get a better prediction, so that we don't predict things that don't come to pass. So my caveat on 5 is, we're taught that failure is bad. That's what we're taught. If you're failure, that's bad. Failure is terrible. But failure is part of step 5. It's part of the process. So sometimes we're going to pick a solution, and it's going to be a terrible solution. Sounded good when we, put it on paper and when we discussed it, and we put it out there in reality, and it just doesn't work. It's just a bad idea. It made things worse. Whether it's, let's say a new design of a dashboard, and we designed this new dashboard, and we thought this was going to be the greatest thing, and it's so confusing to people using it that it makes things worse. And I've seen that happen. I've gotten into different vehicles and I can't figure out the simplest things like, how do I turn on the windshield wipers? And it was somebody said, oh, we think this is a great way to do it. And it turns out to not be a great way to do it. When I bought a laptop, for example, I bought a touchscreen because I thought that was great. Well, it had some drawbacks of now every time I touch the screen, I'm running programs that I don't mean to run. So in retrospect, that probably wasn't the best solution on there, but it seemed like a good idea at the time. So failure becomes a very valuable tool to the engineer in successful problem solving and in making successful solutions. And you'll have a lot of failures, especially in computer programming. You will think that you have it right, and then you will put your program through and it won't work. And it's frustrating because it doesn't work, because it should work, but it doesn't. And so you have to adjust and you have to adapt. And that's part of this problem solving process. But in the end, the advantage is you come up with better solutions than what you would have had originally because of the failures.